everybody. Thank you so much for joining us for What's in the Air, place-based investigations with the new Go Direct Air Quality Sensor. We are so excited to dive into today's webinar with you all, and we've got some really interesting things to talk about. But as folks are kind of filtering into the Zoom room, getting comfortable, I'd encourage you to go grab a snack, maybe a water or an emotional support beverage. But if you're sitting at your desk and ready, I'd love to encourage you to navigate to your Zoom window. At the bottom of your Zoom window, you'll see what looks like a little chat bubble. If you click that, you'll be able to see the webinar chat, and that is where we're going to be taking questions, comments, concerns, ideas, all of the above. Make sure when you go into that chat bubble, right now it might say to, and then have a little blue button at the bottom, and that might be set to hosts and panelists. That might be set to no one. Make sure when you send a chat, it is set to everyone. I ask that for two important reasons. One, this is a space for learning. So other people might be wondering the same things as you. They might be, wondering if it's okay to ask that question they have. So by you putting your question in there, you are making it okay to have that information share, and it's encouraging community. The second reason I ask you to set your chats to everyone is because we will be answering your questions live, and we don't want to look like we're talking to ourselves. So make sure those questions are going to everyone. And to practice this skill, if you are ready, please navigate to that chat window and let me know how many of you just got home from NSTA Anaheim. I know myself and the rest of the Vernier team on this call, we are all settling back in. So I think we'll even talk about, how that data looks. I don't want to give anything away. Let's see. Eric says, I wish I had Eric. It's good to see you on the phone. You were sorely missed. Laura Lee says, hello from Missouri. Hey, Laura Lee. Anybody else? Do we have any attendees? Oh, Jonathan was not at NSTA. Well, that's okay, because one of the coolest things we had there is the new Go Direct Air Quality Sensor. So you've missed nothing. Let's see. Oh, Maribel was there. Wonderful. Yep. Catching up. That is exactly where we're at. Cheryl wasn't there. Stephanie wasn't there. Oh, David is in Portland. Hey, we're neighbors. Wonderful. Okay, my friends, we're about a minute past the hour, and I want to make sure we have plenty of time to talk today. I've got a few housekeeping items for you all. As always, a recording of this webinar will be live both on our website and our YouTube channel. It usually takes us 3 to 5 business days to get that edited. So as soon as it's ready, we're going to post it on our website, post it on our YouTube, and we're going to email it to you. In that email, we're also going to include a resources folder. That resources folder has today's presentation, so that you can go click on the slides, all that good stuff. It's also going to have a certificate of attendance, and a few other goodies. So keep an eye out for that. I'm also going to drop that link in the chat as soon as I'm done talking, so that you can follow along on the slides. We, as I mentioned earlier, would love to answer your questions. So please drop your questions, ideas, etc. in the chat. We are looking forward to seeing those. If we happen to not get to your question, please reach out to us at biology@vernier.com. If you need anything, please reach out there. I believe we're doing, let's see, are we doing a giveaway? We are.
Yeah, gift
Nice.
certificate.
Oh, that's right. Okay, my friends, stay tuned, because we are doing a giveaway at the end of the webinar. Only people who are online still at the end of the webinar will be entered to win, so make sure you stick out till the end. And with that being said, I'm going to pass you off to today's presenters. Thanks, y'all.
Hi, everybody. Thank you for joining us. And I just noticed, because Julianne mentioned it, there's a couple of people, it looks like they might be logged in twice. So if you're hearing an echo, that might be the problem of why you're kind of hearing that echo. So just in case, check on that. So thank you all for coming and joining us today. Just to give you a quick little agenda of what we're going to be covering. We're going to do a brief introduction of ourselves and then an introduction of the sensor itself. I'm going to talk a little bit about why place-based learning. I'm going to talk about getting started with it and kind of basically the fun I've had of doing my own place-based learning, essentially. And end it with why place-based learning can work really well with students and in the classroom. So, hi, just to introduce myself, my name is Colleen McDaniel, and I have not updated this slide with my title at all. Anyways, so I'm a biology and environmental specialist here at Vernier. I went to Truman State University in the middle of nowhere, Missouri. Am a proud graduate of the Masters of Science program from Montana State University. And I taught in Houston, Texas, where I taught pre-AP and grade level biology and AP environmental science. I've been at Vernier for quite a while now, and here I do a little bit of everything. And joining me today, we have Melissa.
Hi, everyone. I'm one of the chemists here, and I will be dutifully answering all your questions in chat. I'm also here to give a little bit of a chemistry perspective for the air quality sensor. So if there are any chemists out there with their chemistry related questions, I am very good at interrupting Colleen and we'll have all our questions answered. So definitely don't be shy with the chat box. And I'm excited to hear more about the air quality sensor.
Yes, do not hesitate to ask questions. That's what we're here for. And hopefully we will be able to answer them all. So, meet air quality. This is been my project that has been something that came out of basically me teaching AP environmental science for a while. And when I started at Vernier, this was a product that I was like, this would have been really, really great for AP environmental science. And I am so glad somebody noticed that it does look like an owl. Yay. My little nerdiness coming out. So it actually was something that I realized when I was teaching AP environmental science that being able to do air quality studies was actually really quite difficult in the classroom. You were really limited to some pretty basic tools. Essentially, I know when I was doing it, and still today, it's the get a glass slide, wipe some Vaseline, then count the particles that are deposited on it over a period of time, or putting a t-shirt around a exhaust pipe and then looking at the weight of that t-shirt before and after, or looking at the particles with that, and then trying to measure the gases. There was a whole bunch of complications and difficulties with it. And over time, the past decade, there has been a lot more air quality sensors that have come out on the market. And it's been great, but a lot of them are a lot more for more household use or industrial use, and just a few really for education. So I wanted to have something that was purely designed for educational use. And really, the way I thought about this sensor was something that was really geared towards student-led experiments and exploration. So this is kind of a more unique sensor for Vernier in that it's really meant for that student-led activity. And what I love about it is that it's meant to be able to do both indoor and outdoor air quality monitoring. So it's going to have parameters that we can be able to measure indoor air quality parameters and outdoor air quality parameters. And once it's ready to ship, it's going to be shipping with the sensor itself. It's going to come with a lanyard so that it can actually be hung from different locations. And it also has a little mount that it can actually perch on, if you will, that can then be attached to a 1/4-20 mount on a tripod so that it can be set out into an area to be able to be placed for monitoring. It also has a hole on the back so that it can be hooked onto a nail or a screw on a wall for mounting as well. The other big thing that will be included with the sensor when it's for purchase is we are going to have a group of lab activities that are going to be included with it. And these are activities that we're going to have a couple sets. One set's going to be a set more AP style that are very inquiry based. And then there's going to be another set that's more NGSS aligned that come with them. And one of the lab activities that I wanted to make sure we included was an activity that really is more of an introduction to the sensor and how to use the sensor. Because as we go through the next few slides, there is a lot you can do with the sensor, and it's almost kind of overwhelming with how much you can do. And so having that kind of introduction to what you can do and getting used to it is going to be key in, kind of figuring out and having students become comfortable with what sort of experiments are available to them. So, what is on it? Well, the air quality sensor includes 3 channels for particulate matter, and I'm going to pull this up in graphical analysis so we can see. It is going to measure particulate matter 1, 2.5, and 10. It measures CO2, nitrogen dioxide, sulfur dioxide, and ozone. It also measures some our common atmospheric conditions of temperature, relative humidity, barometric pressure, and station pressure. Now for barometric pressure, you do have to enter in your current elevation for it to do that correction. And it also has a GNSS chip on it, which is basically a more advanced GPS. So GPS is just the US satellites. GNSS is all of the global satellite systems so that you can get latitude, longitude, and altitude to be able to do geotagging. And I see, Terry, is there a timeline for sales? It is available for pre-order, and we're expecting it to ship in June. Thank you, Melissa. Compatible with Globe protocols. So Globe protocols right now, I don't know if there's any for air quality specifically. I know with things I have not looked fully into Globe. All of our other stuff has been compatible with Globe protocols, so it likely will be, but I have not been able to contact with them because of kind of all the funding that has happened, issues with that right now. So with Go Direct Air Quality, you can see things are a bit different. There is a lot of channels. This is officially our Go Direct sensor with the most channels on it. It has 15 channels. And because of that, that means there is a lot of data that students are able to gather with it. So there's some things that you'll need to keep in mind with collecting data. You'll need to really think about your data collection rate or your sampling rate and your duration. That's going to really affect how many data points you are going to be able to collect. This is something that, again, I talk through with the lab activities of you don't want to get too bogged down in too many data points. More data isn't necessarily better. You want to make sure you have quality data. Also, really great thing about this sensor is it does have remote data logging. So you are able to set it up and leave it in a location so that it can do remote data logging for a period of time and then come back and retrieve the sensor and pull the data off of it. For example, I set this up in my house for about 24 hours and ran it to see just kind of what the CO2 levels in my house did overnight. And for a full 24-hour cycle, our HVAC wasn't running, so it wasn't too exciting. Sorry. Nothing too thrilling. The other thing that's interesting is that it does measure VOCs, but it measures VOCs via what we call a VOC index. So it does not have units. The VOC index is this range of values from 0 to 500. And the way I describe it is that it basically acts like a nose, where 100 is actually your baseline, And anything above that is going to be above normal, and anything below that is kind of below normal, so lack of scent. So it's kind of an abstract, kind of strange thing for students to think, but it's very obvious. Like when you put a marker in front of it, you're going to get a really big peak in that VOC index because it's going to have that big peak with it. But then it basically adjusts to it and will come back down because it's adjusting to those odors in that place. The other key thing with the sensor is going to actually be placement of it. That students will have to think about where they're putting this sensor for where they're doing collection. So for example, if they're collecting data and looking at emissions of vehicles going by in an intersection, they'll need to think of where in the basically thinking of like the air column, where will they want to place the sensor? Will they want to place it on the ground? Will they want to place it, 6 feet in the air, 4 feet in the air? How are they going to want to put that? If they're doing data collection inside of a room, where in that room will they want to put that? So that's something else that they'll need to start to consider and really think about with some of these experiments. Also with the documentation that comes with the sensor, we also have like a little map that shows you where all the features and sensing elements are on the sensor so that you can understand where everything is placed as well. Any other questions so far?
There was a question about battery life. I don't know if you want to elaborate.
Yeah, so battery life, I've so far run it for 24 hours and 36 hours with quite a few channels on, but it's going to be very dependent on the number of channels we have running. Some sensor channels are going to take more power than others, so we're going to see a bit of variability. What I have found is if you have an external battery to it, you can keep it running for longer. I've also actually plugged it into a USB plug, like basically what I would charge my phone with. And I had it running for, what was it, 16 days and connected to my iPad that entire time. And it collected that entire time just fine. So it can go for quite a long time. Oh my goodness. A bunch of things just came in here.
Yeah, just like everyone's sharing their great
Yeah.
ideas for applications. So why don't, yeah. I didn't
That's
know
it.
if you were gonna show it to show them some data.
Yeah, I'm going to talk about some place-based learning and then I'm going to share some of the data that I've collected as I've been playing with it over time here. All right. So one of my little soapbox things that when I was teaching AP Environmental Science was all about doing place-based learning. My school I taught at it was a pretty urban school in Houston, Texas. And it was kind of the school that we weren't actually in HISD in Houston Independent School District. We were actually in a smaller district that was basically swallowed by the Houston Independent School District. So we were kind of in this neighborhood, but still in a very urban area. And my students still didn't have an idea of like really what was the environment around them like. So I really took time to get them outside, even though we were just on campus, to kind of have more local exploration and really start to get more personal connection with the area around them. It gives them more kind of connection to those real local issues that are affecting the area and kind of more ownership. The other reason I really like place-based learning is you kind of move away from these like really kind of perfect labs that we tend to do. A lot of the labs that we tend to do in classes often tend to be these very predictive, you change this variable and then this effect happens. We change variable X, this effect happens. Then we change it to Y, this effect happens. But when we're looking in the environmental space, it's messy. It is super, super messy. There are so many external variables taking place. You cannot control for every single variable out in the environment. And it's really hard to interpret a lot of that information. And so being able to show students that that is what reality is like is super valuable for them. It allows them to have a lot more critical thinking and to really see how they can kind of make conclusions, but still have discussions and unknowns based on the data that they're getting. Environmental literacy is also something that's super important nowadays, of them being able to have just observational skills, of being able to observe the world around them and kind of get that sense of place, of have that stewardship and that kind of ownership of having the world around them. And then lastly, just having them engaged. One of the things my students would do was just, honestly, I would get them outside to pick up trash and we would talk about things that we were seeing as we were walking around. And that would really kind of pique their interests. So, how to get started with problem-based learning? Number one is just get students out there. Like I said, I would take mine out to pick up trash. And while we are out there, I would have them making observations. What do they notice? What do they wonder about? And the key is really letting them decide, but kind of encouraging them and letting them lead the way. And kind of keeping those conversations going to help them kind of design and lead those questions into experiments that they could do. But that you also have to, at the same time, things that you'll have to keep in mind with this place-based learning is kind of have some restraints on it. Because I remember when I was teaching my seniors, the ideas that they would get were just off the rails. So things that you'll have to keep in mind are what tools are going to be available for them to use. Like for example, if you don't have an air quality sensor available, a weather sensor, or a light and color sensor, or just even a temperature probe are super useful tools to help them start to explore. What are the limitations that are going to be out? Are they able to do this outside a class period? Are they limited to certain class times that they can do this? What time of year is it? What is the temperature outside? Is it hurricane season? Is it winter? Is it spring? Any of those things are things to consider. Other questions that they have to think about is a project doable? Students might want to think about going onto a roof or climbing a tree. Not necessarily doable. What is practical? Are things that they can do within a practical time period? These are all things that you need to help kind of have them think about, because the imagination and wonder where they go is fascinating. It's great, but you also have to kind of start reeling them in and pulling them into things. So this is where I started going off the rails with mine. So as soon as I got the air quality sensor, one of the first things I did was like, I have a gas stove. My gas stove puts off carbon dioxide. I wonder what would happen when we cook dinner one night. So my husband and I were making dinner one night, and I set up the air quality sensor while we were cooking dinner. And this is just a screenshot I took of the graph, the data I collected. That here is where I started just as we turned on the gas stove. You can already tell my CO2 levels were pretty high in the house. Probably should get this open some windows here, but it was in the winter. And then here's where we turned on the gas stove. And you can see as the gas stove was running, my CO2 levels in the house started to really increase there. At the same time, these are my different particulate matters. And this here is when we were starting to saute some mushrooms and then put a steak on the skillet. As we were pan frying that steak, you can see our particulates went really way up here. So that was just one of my fun things to do there. Then some other things, I'm going to stop sharing this screen and get into some graphical analysis data here. So just to kind of show you here of connecting my air quality. Oh, I need to share my screen. I'm going to do this. All right. So everybody should be able to see my graphical analysis. I'm going to kind of go back to where I was. So I'm doing sensor data collection. And I have connected my air quality sensor here. And you can see here are all of my channels. Right now I have it's set up automatically when you connect it that it will detect PM 2.5, carbon dioxide, and temperature. I'm going to go ahead and turn on relative humidity as well since I'm in this room by myself. And for now, I'm just going to set those and I'm going to click done. And I have all of these graphs up here. I'm going to turn on some meters so I can look at my live data collection. And you can see based on my CO2 levels here, I am definitely in a room with no windows that is pretty closed off with very little circulation right now. And I'm going to go ahead and set some data to collect while I'm going to be showing you some data that I've collected over the past few weeks here. So I'm going to go ahead and change my units to minutes. And we're going to go ahead and collect data for, let's go for 10 minutes. And I'm going to collect 30 samples a minute. And here's the key thing. I hear that where it says remote logging, I'm going to enable that remote logging feature right here. So that's going to enable me to then, when I click done, I'm going to have this button up here that says start logging. And then once I click start logging, this is going to give me information that says I now have activated logging. And it gives me my information on what my data, my flashing LED indicates. Let's see if I can get this in focus here. You can see my Bluetooth LED is flashing green. That means it's currently collecting data. I can click OK. And then just put it to the side. And then I don't have to touch it for another little bit here. So
before you go on, I just there might be a little bit of confusion. You don't have to set it up that way.
no, you don't. That's me just demonstrating it. And I'm trying to get back in focus now.
Yeah, the remote logging is just for if you like want to set it outside and take your device away from it. So like the Bluetooth connection will be lost. Remote logging means you can leave the sensor there and you can walk away from it. You can leave it out overnight. You could put it in your greenhouse for a week. But if you're going to be there, if you're going to be in the classroom all day and you just want to see what the kids are doing and it's going to be connected to its own device all day long, you don't need to set it up that way.
Correct. Yep. Sorry about that. Sorry, I'm going to try to get focus back in on my face here. There we go. Yeah, so you can do live data collection as well as remote logging. I just wanted to show kind of a remote logging example because it's something that's newer for us that we really haven't been able to demonstrate in a webinar quite yet. And that's one feature of this product that is actually quite important for a lot of being able to do a lot of the data collection that it's able.
This is taking too long to type, so I'm just going to answer the question live while you figure that out.
Yep, sorry.
No, you're right. Yeah, so this is a GoDirect sensor. All of our GoDirect sensors can connect via Bluetooth or USB to any device. So a Chromebook, a MacBook, PC, Windows, iPad, Android device, all of them can connect via Bluetooth. So the app you want is the free app called Graphical Analysis. And you can use it in an app that you download, like on an iPad, but you can also just open your Chrome web browser, like on a Chromebook, and type in graphicalanalysis.app to connect. And I think Colleen showed some of that, and so you may have missed it, but that's kind of the recap on that.
Yes. I'll show again on how to connect it here once I get everything running again. That is, it keeps.
These do not, yeah, they will connect to a LabQuest, like a LabQuest 2 or LabQuest 3. You don't need a LabQuest Mini because they are USB devices. And students can also download this app and what? Yes, they can. So it's free app, graphical analysis. They can download it as long as they have a device because Bluetooth connection 1-to-1. Yeah. All right. Now you found it. Yay.
Yay. Sorry. I'm not used to Windows computers. And it kept opening it in the background here. So this was another indoor air quality experiment I did where I was in my office at home and I had the blue line up here is when I ran for I believe this was just a minute where I had it running for a minute to see what my air level was with my window closed because it was pretty stuffy. And then I opened my window and pretty much immediately saw the CO2 levels drop. But at the same time, my particulate matter started to increase with my window open because more pollen was coming in around at that time and more dust was coming in. So that was kind of interesting to see kind of that combination thing going on there of you have good thing to come with air quality, but then you also have to balance the potential bad with it as well. So this one here is the one I collected last week when I was in Anaheim. So I went down to for NSTA, we were in Anaheim, California. And so I took advantage of being in Anaheim and decided, you know what? That's right by LA. I might as well fly down a little early and do some driving around LA to see what some air quality indicators are around there. And so I went to 9 different locations where I set up the air quality sensor. I rented a car and set up my air quality sensor. I created my own protocol where I parked in a parking lot at each of these locations, put the air quality sensor outside my car, actually took the lanyard and hung it from the window outside and let it sit there to equilibrate for 5 minutes before I took a data point. And these are the data points that I took at each location throughout the day. So these are the particulate matters for each one. So let me get my legend. Here you can see the PM1, 2.5, and 10. And you can see pretty interesting, consistent. What I found interesting here, the Dockweiler and the Bolsa Chica place location, these two here with the highest PM10, those two are the ones that were basically directly on the beach. So really picking up sand particles within the PM measurements there. Also, that's where we're getting the highest 2.5 measurements as well, which was kind of interesting. I could also go through and look at, my NO2, these ones we're still kind of working on getting our calibrations right. You can see I had some negative NO2s. Those we'll just ignore for now. But I can compare my nitrogen dioxide and my ozones there. And as I was getting later in the day, I was starting to see more ozone increasing and nitrogen dioxide going down, which is what I would expect because of the photochemical reaction taking place that converts nitrogen dioxide to ozone. So I was definitely seeing some very interesting things take place throughout the locations. Then what I thought would be really interesting was, I'm going through all these places, so why don't I map these things as well? Because I would like to see where these are in space and where these data points were. So because I took those latitude and longitudinal data, I went ahead and mapped the locations and I uploaded the data into Google Maps, which then allows me to actually plot the data onto a Google map. And here I can actually pull up my data points. Oops, my information's in the way. And as I click through, I can actually do some comparison and see exactly where I was at these different locations on the map. And I can even change my base map around and kind of get a better idea of exactly kind of the geography of the areas that I was in, of really seeing, okay, here in this area where I had much higher ozone than nitrogen, I was at a much higher elevation here and kind of more coastal down here, and be able to really kind of visualize what was taking place. The other interesting thing I did as I was going was I thought, what would happen if I took data while I was flying? So I found out you can actually get coordinate data while you're on an airplane. And I could actually get my data points flying through there. So I can actually track my entire flight route as I was coming down here, and you could actually zoom in and I can see the approach my landing took. And then you can see as I landed in LAX, I had to come through the airport and I landed, and then I had to take the transit out to get to my rental car location out here in Hertz Rental Car to pick up my rental. And then I can click on each data point, and again, it's going to give me my information of what values were collected at each of those locations there. And so let's pull up the data from that one. So here is the data that I took on my flight, which I thought was pretty interesting because I knew the CO2 levels would actually be pretty high on the flight. And I'm going to change my graphs here so they're a little bit easier to see. So this is my particulate matter, which interestingly was fairly low to the beginning, and oddly, about almost an hour and a half into my flight, had this weird peak that occurred. No idea what happened here, not sure why. But then this is about when I deboarded the plane, and you can see definitely when I got off the plane is when the particulates really started to increase. So overall, the plane had very good filtration and ventilation going for particulate matter. But then if I go instead and look at CO2 levels, we had some really high CO2 levels throughout, and then had a huge drop as soon as we had got off the plane here and into fresh air, that we went back to a little bit lower levels as we're kind of getting off the plane and going through the airport. And then it's kind of an interesting thing to look at, and like looking at the station pressure, you can see, this is, when we were taking off, going up, and then kind of the pressure really decreased as we were in the flight, and then increased as we came down again, back to sea level. So there's a lot of kind of fun, interesting things I got to explore while I was, on an airplane and getting to process the information afterwards. Okay. I see a lot of questions in chat, Melissa. Are you
So
keeping
many
up?
questions. I'm furiously writing. I hope I got to
I'm sorry.
everyone's. It was really good questions. Maybe touch on maintenance. I want to make sure I got all that right with calibration and
Yeah.
solutions and lifetime.
Okay. Okay. So let me quick talk here. Okay. So maintenance. There are some light filters that will need to be replaced over time. I'm going to make some videos on how to do that. They can be replaced by you. The particulate sensor at the bottom has a self-flushing mechanism, so that should not need to have any action by you to need any cleaning or maintenance. We do have some mechanisms in there to basically give you an alert if it does need to come in for maintenance to us. Basically an LED signal to say so. The sensor itself, if I remember correctly, is going to have a 5-year warranty on it, but we've been told the electrochemical cells are supposed to last for 10 years. So they should be good. The other big thing is that it is water resistant, not waterproof.
Yes, I had someone ask about the rain, and I know if it's in a tree or something, some
Yes.
light rain, it should be pretty good, but maybe
And
not
the
a
big thing
storm.
I always emphasize with air quality and rain is you shouldn't really be measuring air quality during rain events, because the rain is already affecting the air quality by like basically pulling all the pollutants out of the air. For example, today we had to completely pivot on today's webinar. We are actually going to be outside collecting data live, but it's raining because it's Oregon and spring. And it's the one day that it's rained in like weeks. Yay. So it's kind of we do have some things on it to make sure that the electronics are as protected as can be, but definitely try to keep it out of a rain shower. It is so new for us. We don't have necessarily a prescribed schedule for filter placement. So we are going to be all figuring it out exactly if there is a prescribed schedule for filter placement, and are hopefully going to let you know. Kind of trigger, yeah.
Like for remote dating?
Yeah, so triggers available for starting its collection. Basically, there are the triggers are going to be triggers are used a lot for physics data collection, and I'm trying to figure out how to adapt them to use them for environmental. It's usually based on changing over a certain area, a data period. So basically, you'll want to think of like a change in temperature is usually what I started to think of like, you'll want to trigger it so that if the temperature is really like a lot warmer or a lot cooler outside than inside, is that you want to check the trigger so that it is changing that temperature when you go outside, that's going to be the trigger to start the data collection, or humidity change or
Yeah,
something like that.
I could see some interesting applications of some of that.
Yeah. Okay.
Yeah, no, we had great questions. People have great ideas for how to use it.
Awesome.
Yeah. So, but I think we got most of them answered.
Awesome.
I pointed people to the website for all the list of sensors
Fantastic.
and specifications because there were some questions about that. It's on the website, so definitely check that out.
I'm going to quick pull off the data of my data sharing so people can quick see the
Yeah.
demonstration of how that looks. So my LED went from blinking green to blinking orange now. Yes, that is the one I am using. So let me share graphical analysis. And we're going to click on sensor data collection. I'm going to connect my air quality. Takes a little bit to connect because there's a lot on it. And so when you are data logging, it will recognize that there's log data and have this message come up. I'm going to click retrieve and clear. So it's going to pull the data off and then clear the memory from the data. And this is our very exciting data of it going for 10 minutes in the room with just me. I'm going to press some zooming in here so we can see nothing really exciting happened. Not very surprising. But CO2 actually went down as I moved it away from my face. I am so not surprised.
I think the only thing left is the giveaway, right? Because I'm pulling it up right now. Yeah, what other questions?
Yeah, I think that's it.
Yeah. And the giveaway.
Yes. So we are giving away a certificate for $100 to Vernier. You can use it towards this sensor, different sensor software. If you don't know how to use it, call us. We can help you with that too. As Colleen and Melissa were chatting with you all, I entered everyone's names into a random name generator, and today's winner is Stephanie M. So if your name is Stephanie M, congratulations. I am going to go ahead and email you. I have your email from when you registered for the webinar, and I just need to get some information about how to get that certificate to you. So congratulations, Stephanie, and I hope you all, I just changed my name to Stephanie. So
Some
yeah,
quick
I hope to see
paperwork.
you all. Yep. All right, friends.
Yes.
When you close the Zoom meeting, you're going to see a link, or maybe it'll just populate for a survey. So, Ed, we just want to know, what you thought of today's webinar, get some feedback from you. We'd love to have an idea of what you want to see for future webinars. So, if there's something you've been wondering, something you've been kicking around, could be over the summer, could be in the fall, could be in the winter, anytime, drop it in there. We'd love to hear from you.
And if you have any questions, please don't hesitate to reach out. You can reach me at biology@vernier.com. Happy to take questions, happy to take any crazy ideas you have of
Yeah, let us know how you want to use it.
how places to go, things to use it with.
Amen. All right, bye everyone.
Bye, thank you.